Good morning. Today we'll be talking about congruent triangles again. Yesterday, or the last lesson, we learned about side, 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 and side, angle, side. Today we're going to learn about angle, side, angle, and angle, angle, side. Notice I have ASA and AAS. Our goal will be to determine if the two triangles are congruent using those two, ASA, the postulate, and AAS theorem. So let's begin with the postulate, angle, side, angle. It says if two angles in the included side are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So if I have a triangle ABC and I've got an angle, a side, and an angle, notice the side is included, then another triangle DEF, notice an angle, a side, and an angle. Notice the side is included, so let's write our congruent statement. So angle A is congruent to angle D. AB, side AB, is congruent to side DE. And angle B is congruent to angle E. So notice we have a pair of congruent angles, a pair of congruent sides, a pair of congruent angles, and that the sides are both the included sides. That's all we need. We don't need the 6 congruent statements. That's angle, side, angle. That tells us that the triangles are congruent. Then we have a variation of that. We have the angle, angle, side congruence theorem. So this is one that can actually be proven using the postulates we've learned, in particular the angle, side, angle congruence postulate that we just learned. So let's look at this one and think about it just a second. I'm not actually going to write out the proof, but I will mention it. We will talk about why it works. So let's name them ABC and DEF. Let's do our angles, and let's see our non-included side. So at this point, this is very similar to what we just saw. If we start writing our congruent statements, let's see, angle A is congruent to angle D. Angle B is congruent to angle E, and side BC is congruent to side EF. So this is very similar to what we just saw. It's again two angles and a side, two angles and a side. The difference here is on angle, side, angle, the side was included. It was between the angles. Here, the side is not the included side. It's a non-included side, but the three angles of any triangle equal 180. So angle A plus angle B plus angle C would equal 180. So I guess I should write the M here for the measure of these angles. Same thing over here. The measure of angle D plus the measure of angle E plus the measure of angle F is 180. Using the transitive property, this stuff equals 180, this stuff equals 180. I know that A plus B plus C equals D plus E plus F. Now, looking at our congruent statements, I know that A and D are the same. So if I subtract the measure of angle A, that's the same thing as the measure of angle D. They'll cancel each other out. B and E I also know are congruent. So if I subtract the measure of angle B from the measure of angle E, they will also cancel each other out. I'm left with the measure of angle C is equal to the measure of angle F. So if I know that this angle and this angle are congruent, I have ASA. So AAS is just a variation of ASA, because if AAS is there, I know ASA is there, which tells me the triangles are congruent. So if I see this scenario, angle, angle, side, where the non-included side is congruent, then I know my triangles are congruent. So be careful with ASA and AAS. They're variations of one another, but very, very similar. Just as useful as the side, 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 and side, angle, side that we learned about in the last lesson.